8.3, we're going to look at hyperbolas. In a lot of ways, hyperbolas are similar to ellipses, but in a few ways they're pretty different. So if we look at it centered at 0, 0, first off, please correct your chart if you printed it off for me, because that should be a squared first and then b squared. And in this case, a squared is not necessarily our biggest number. It's the one that comes first between x squared and y squared. The next few things look the same on our chart, the focal axis and the foci and the vertices. Then we have these new words over here for our axes. A gives us the semi-transverse axis, which is pretty much the same thing as saying our major axis. And the semi-conjugate is really like saying our semi-minor axis, but they get new spiffy names for some reason. The Pythagorean relation changes just slightly. Instead of a minus sign for ellipses, we have a plus sign in the middle for hyperbolas. Our new thing here is we have asymptotes for hyperbolas, so that's new. You actually get these equations by, if you put a 0 here instead of a 1, and then you solve for y, it gives you these equations, so that's kind of neat. So let's look at some examples. This is going to work very similarly to the way that we did ellipses, and even in some ways the way we did parabolas. So this first example, let's start by finding the vertices. To find the vertices, we need to know what A is. Also, it matters that Y is in front, so I'm going to use the second column. So to find A, I square root 25 and get 5, so my vertices are 0, plus or minus 5. My foci, or foci, depending on your pronunciation, comes from this Pythagorean relation, a squared plus b squared equals c squared. And so what we do is, since these numbers are a squared and b squared, we just add them together and then take the square root, and that's going to give us c. So it's going to be the square root of 46. So our foci is 0, plus or minus the square root of 46. So again, we're just kind of looking at our chart, letting it help us. On the next one, sketch the graph by hand. So these are actually pretty easy to graph, although they're kind of weird to graph. This is centered at 0, 0 because it doesn't have parentheses on top and because it's on the centered at 0, 0 slide. What we want to know is basically A and B. A in this case is 7, B is going to be 25. And what we do is, from here, we normally on an ellipse draw an ellipse. I didn't add my lines the other way. But here, we're not drawing an ellipse, we're drawing a hyperbola. So we're going to draw a box. That box is going to be 7 to the left and to the right because the 7 is under x. And it's going to be up and down 5 because 5 is underneath y. And so draw yourself a nice quadrilateral. Okay, step 1, draw your box. Step 2, draw diagonals in your box that are dotted lines because those are your asymptotes. Step number 3, and this part is the only part that's actually our hyperbola, is this part that we're about to draw. But I want you to draw this whole thing. You have to draw all of this to actually get all the points on the graph. Since x squared is first, we're going to draw our graph on the left and right side of our box. Our vertices are here at the edge of our box, and then we go kind of like a left and right opening parabola towards our asymptotes. So here's our vertices on that side, or our vertex on that side. It goes toward our asymptote. And incidentally, if we wanted to say what our vertices were on this, we would have plus or minus 7, 0, and if we look at our graph, that's where those orange dots are that I graphed. I mean, we could do our foci as well. They'd be the square root of 49 plus 25, which is the square root of 74. And as far as where that is, the square root of 74 is somewhere between the square root of 8 and 9. Our foci in this particular case is a dot that's out here. kind of like how the focus was in our parabolas, that it's on this side of our graph. Okay, so there's a sketch by hand. Now let's look whenever we're centered at HK. So this does change up our equations from 0, 0, the same way it did with ellipses. And I messed up again here on that chart, so make sure that you change it to a squared, then b squared. But otherwise, it's all going to be pretty much the same way that it was on the previous slide. So on this example on the bottom left, oh no, we're not in standard form. So to get in standard form, we need a 1 on the right side, so we divide everything by 1. So this is x minus 2 squared over 9 minus, this would be y plus 1 squared. The 9's cancel out, but if we wanted to, we could put a 1 on bottom, just kind of a placeholder to remind us that that's there. So a is going to be 3, because that's the square root of 9. B is going to be 1, which means c is going to be the square root of 9 plus 1, which is square root of 10. So for our vertices, now this time we're looking up here at this h plus or minus a comma k. Our h is 2 from our center point. Our k is negative 1 from our center point. I could have gotten it from this instead, actually, whichever. So I'm doing h plus a, so 2 plus 3 is 5, comma k, and I'm doing h minus a, so 2 minus 3 gives me negative 1, comma negative 1. There's my vertices. And then my foci would be the h plus or minus c, and so since c is a square root, I'm just going to do 2 plus or minus the square root of 10, comma negative 1. So there's that. Now let's sketch this by hand over here. So we want to do, our center point is important. It's negative 2, comma 1. A would be 3, B would be 5. We don't necessarily have to find our vertices, but we might as well. Our vertices are going to be h, comma, so h is negative 2, h, comma 1 plus a, which is 4, and h, comma 1 minus 3, which is negative 2. And then our foci are going to be negative 2, comma, we would do the square root of 9 plus 25 to get c, so that's the square root of 34. So that's going to be 1 plus or minus c, which is the square root of 34. Okay, now for the actual graph, since that's what they want from us. We would go to our center point, so left 2, up 1. We would go left and right 5, because B has to do with X. 1, 2, 3, 4. And then up and down 3, because 3 is underneath Y. Draw your box. And draw your diagonals. If we wanted to put our vertices on here, we said they were negative 2, comma 4, which is up here, and then hey look, it's going to go up from there because y is first. That's the way that goes. Then negative 2 is right there, and then it's going to go down from there. So that's how you do it if it's not centered at 0, 0. Alright, the other big section that we have here is finding an equation in standard form for the hyperbola that satisfies the given condition or conditions. And so part A, it tells us the foci is plus or minus 3, comma 0. So that means that this is going to be centered at 0, 0. Otherwise, it couldn't be plus or minus a number, comma 0. And then the transverse axis length is 4. If the transverse axis length is 4, that means that A is half of that. Well, no, not half of that, sorry. Yeah, half of that. Half of the length is 2, okay? So A is 2. If the foci is plus or minus 3, comma 0, that means that X has to come first. Okay, and then it also means that C is 3, because plus or minus 3 is what we have. So we know that A is 2. We probably should try to find B. And then we know that C is 3, so we're going to end up doing 3 squared minus 2 squared, which is 5. And then we're going to square root both sides and get the square root of 5. But then underneath x squared should be a squared, which is going to be 4. Underneath y squared should be b squared, which is actually going to be 5. It equals 1. So there's my equation. I don't know what happened here on labeling these with letters, but here we go, A, B, C, D. So now we're on B. It's centered at 0, 0, so we know what chart to use. It tells us A is 4, E is 3/2, and the vertical focal axis, or our focal axis is vertical. So if our focal axis is vertical, that means that it's the y-axis. So we're going to use the second column. Also, my box for eccentricity is on the next slide, but remember that E equals C over A. So they gave us what E is. It's 3/2. And they gave us what A is. It's 4. So there's actually a couple different ways to do this. We could use proportions pretty easily or cross multiply. Either way, we should end up that C is 6, which means that we can find B, because A is 4, so 4 squared plus B squared equals 6 squared. So 6 squared minus 4 squared. I believe that that is 20. 36 minus 16. Let's not even bother square rooting that, because what we need in our formula is actually B squared. So I'm sorry, that's not really supposed to be an x squared. We said our vertical axis was the focal one, so that means that y comes first, and that underneath y squared should be a squared, so that should be 16. Underneath x squared should be b squared, which is 20. It equals 1. The transverse axis endpoints. Now here we are looking at something where the center is not HK. The transverse axis endpoints are -2, -2, -2, 7. The slope of one asymptote is 4, 3. So the endpoints for the transverse axis. The transverse axis is the one that has A on its length, and so that means that our transverse axis endpoints is actually telling us our vertices. If it was opposite, if it was telling us about our semi-conjugate, it wouldn't be telling us our vertices, but it would be telling us something about B. So these are really our vertices. So that means that H is -2 because it's the same in both. K should be what's halfway between -2 and 7. Those are 9 apart, so that means that 4.5 are away from each side. So basically what I'm saying is that one of these is K plus A, and one of these is K minus A. And so we can set up a system for that, and it doesn't matter which way you go. But if you wanted to make the plus the one that's 7 and the minus the one that's -2, because why not, then go for it. So that would be 2K equals 5. So k equals 2.5. Okay, because that is what's halfway between -2 and 7. So how far is it to get from k to 7 or from k to -2? Like, what is a? Well, you can plug it back in. 2.5 plus a equals 7. So you'd subtract the 2.5 over and get 4.5. Okay, so what else do we need? We have hk, we know what a is, and then it says the slope of one asymptote is 4 over the square root of 3. So, since this has to be from the second column of our chart because h stayed the same in both cases, then our slope for our asymptote is plus or minus a over b. And they're telling us that it's 4 over 3, but we just found that a is 4.5. So we need to figure out what b is by cross multiplying. So I'm going to do 3 times 4.5 and then divide that by 4, and I should get 3.375 for b. This took a kind of a crazy turn here, didn't it? So we don't want x first, we want y first because h stayed the same. Okay, so y minus 2.5, or we could use fractions for this. I don't know why I'm using decimals, over a squared. So 4.5 squared is 20.25 minus x plus 2 squared over 3.75 squared, 14.0625. Okay, that one was kind of complicated, so that's more of a worst case scenario kind of situation. So part D, last but not least, foci of -4, 2 and 2, 2, transverse axis endpoints of -3, 2 and 1, 2. So again, transverse axis endpoints are the same as our vertices. So the 2 doesn't change. There's a 2 in both of them. That's our y value for our center point. We're looking at our first column because basically I'm saying that this has to be like h minus a comma k, and this has to be h plus a comma k. Since both of them have 2, then k has to be 2. Then we can do h minus a equals -3, h plus a equals 1. We can solve that. H equals -1, which means that a equals, if I put in a -1, a equals 2. Okay, so then we just need to find b, and we're going to do that because they told us about the foci. So the foci are h plus c comma k. That's not a c. H plus c comma k and h minus c comma k. And so we already know that h is -1, which means that c has to be 3. Yeah, 3. Basically, these 2 points are 3 away from h, which is our center value. So if I know that a is 2, and I don't know b, I want to find b, and I know that c is 3. I'm doing 9 minus 4 is 5, so b squared equals 5. Now we're ready to write it. X is going to come first, x plus 1 over a squared, which is 4, minus y minus 2 over b squared, which is 5. Alright, now we want to look at eccentricity and a word problem. So eccentricity is, in computing, is very similar to an ellipse. We just have a plus sign underneath the square root if you want to use that part of the definition instead of a minus sign. But it's still c over a. You just, for hyperbolas, compute c differently. So that's why this part of it's different. And then I messed this up, so change that word to hyperbola if you printed out the notes. So we've got in this problem a comet following a hyperbolic path about the sun. And so I'm going to draw an x and a y axis. And we're going to draw the sun over here on our x-axis. And then what's going on is that we have this comet that's following this hyperbolic path, like so. Which means that if we were drawing this graph, we would have a box, okay, and we'd have asymptotes, and my box is not particularly accurate, particularly on the left side, but something like this. So notice that basically what's happening is the sun is giving us our focus for this side of our what's it called, hyperbola, and so this point is c comma 0. This point right here, which is where at some point the comet is, let me try a different color. This point right here, at some point our comet is there, and that's our vertices. It's on the x-axis. That's a comma 0. They tell us in the problem, I think there's the word distance here. So a comet following a hyperbolic path about the sun has a perihelion distance of 120 GM. What that is talking about is this distance inside here is 120. So the distance from 0 to here is a, because that's the vertices, okay, and so that's a comma 0. The distance from 0 to the sun is c in this case, because that's how far it is to get to the foci. And so in between those, we've got this 120, so that means that c minus a is 120. The other thing we can know actually comes from, randomly in the book, they show us that, and actually they ask us in an exercise to prove it, but we're not doing that exercise. They say the focal width of a hyperbola is b squared over a, and so they give us, when the line from the comet to the sun is perpendicular to the focal axis of the orbit, the comet is 250 GM from the sun. Well, that's going to be our focal width, basically. And so that's gonna be helpful to us. So we're saying 250 equals b squared over a. So we could actually solve that for b squared and get this, b squared equals 250a. We know that there, for hyperbolas, is this relationship a squared plus b squared equals c squared. But if I rewrite that, which I don't know that I have to rewrite that, but let's rewrite that as c squared minus a squared equals b squared. Now I have a system of equations, and I'm going to basically solve out this system of equations. And actually this right here is the other thing we're going to use. We're going to use these three equations that I have. So let's plug into c squared minus a squared equals b squared. I'm going to take this equation and say that's really c equals 120 plus a. And so that's going to go where c is here. And for b squared, well, we know what b squared is. It's 250a. Now I should be able to simplify this and solve. So we have to FOIL this out. This should be 14,400. minus 240a. I don't know why I said minus, that's a plus, plus a squared, minus a squared. Oh, how convenient. So my a squareds cancel. I'm going to move put my a's together on one side, and that's going to give me 10a equals 14,400. So a equals 1440. The units on this is GM. So in the problem, it asks us to calculate A, B, C, and E. So here's A. So for B, I'd plug that back in. So let's plug back in for B. So where's a good place to do that? I guess this right here is going to have to do. So B squared equals 250 times 1440. So what we're going to do is, in our calculator, 250 times 1440, and then square root it. 600 is B. So we've got A, we've got B. C is using that Pythagorean relationship, so 1440 squared plus 600 squared equals C squared. So 1440 squared plus 6, that looks like 660, but that's still supposed to be 600. That's 1560. How convenient that that comes out to a nice number. And E is C over A. So 1560 divided by 1440. 1.083 repeating. I wonder if that's a well, I guess we want the decimal otherwise. No, not necessarily. What is that as a fraction? 13 twelfths. 13 twelfths. That does not have a unit. Our units would have canceled each other out. That's all they want us to find, and then it also asks us what are the coordinates of the center of the sun if the center of the hyperbolic orbit is 0, 0, and the sun lies on the positive x-axis. So the center of the sun, the middle of this is the foci. We just need to say that the sun lies on C, which is 1560, comma 0. Ta-da!